Section 10.1, conic sections. Can anybody tell me what conic sections are?
Sections of cones.
Sections of cones. And what do you get when you take sections of cones?
Area under a curve.
Perhaps. Not exactly what we mean, though. Well, there's some pretty pictures in your book here. What happens when you take a cone and you cut it straight across? You get a circle, so that's called a conic section. How about if you take a cone and you cut it at a diagonal? Well, it depends on how steep your diagonal is. If your diagonal is steeper than the steepness of the cone, you get a parabola. If your diagonal is less than the steepness of a cone, then you get an ellipse. And if you take two cones, one on top of the other, and you cut perpendicular to the two cones, then you get what's called a hyperbola. So the classic conic sections, when people talk about conics, the classic conics are circles, parabolas, ellipses, and hyperbolas. Those are known as the conics. And they do point out that you could also cut a cone in a certain way to get a point. You could cut it to get a line, and you could cut it to get two intersecting lines also, depending on how you want to cut it. But it's the top four that we usually consider the classic conics.
When you cut it, do you look at the shape that's left or the shape it makes with the cut?
The shape it makes with the cut. So for example, it's hard to see here. They're cutting it with this plane, and so they're looking at kind of the trace of the cut that's left. And so the trace of the cut that's left kind of looks like that, which is the parabola. In this one, the cut has that kind of shape. So basically you're thinking of slicing it and then looking at the object and what shape is there on the face that you cut off. Okay, so let's talk about circles. First, what do you know about circles?
A equals pi r squared.
Okay, you know a formula for the area. The area is pi r squared. What else do you know about circles?
X squared plus y squared.
Okay, a circle centered at the origin will have the equation x squared plus y squared equals r squared. What's r? Radius. And I said something about centered at the origin. What's the center?
0, 0.
In this case, it's 0, 0. What's the center in general of a circle?
HK.
Okay, there's a different formula. If I want the circle centered somewhere else, my center would be HK, is the way it's usually given. I guess what I'm looking for is, what's the definition of a circle? What is a circle?
Evenly round.
All points around the circle have the same distance.
All points around the circle have the same distance from the
Origin.
center, or maybe the origin, but in general the center. So that's the classical definition of a circle. All points the same distance from a fixed point. What's this fixed point called? Begins with a C. Center. And what's this distance called? The radius. All right, so a circle is, you fix a point called the center, and then you measure a fixed distance away. So this distance is r, and it's all the points that are the same distance. And of course, when you draw a circle by hand, it never really looks like a circle, but you get the idea. The radius is always the same. It's okay, it's got a little bulge at the top there. Not quite right. Okay, so what if I gave you this equation? X squared plus y squared plus 4x minus 6y equals, I don't know, 12, maybe. You should recognize that that equation is the equation of a circle. How do you recognize when an equation is the equation of a circle? It has x squared and y squared, but it has to have something more than just having an x squared and a y squared. For example, if this one was 3x squared and that one was just y squared, it would not be a circle.
Coefficients, the highest power.
The coefficients of the highest powers have to match. If this is a 3x squared, then I would have to have a 3y squared to be a circle. What if they don't match?
Circle.
And it's not a circle. That's correct. What shape is it?
No ellipse.
Maybe. Usually an ellipse. We'll talk about ellipses here in a few minutes. If the coefficients do not match, then it's either an ellipse or a hyperbola, depending on the coefficients. Okay, so this is a circle. You recognize something as a circle when it has both an x squared and a y squared, and those coefficients match, and they're almost always given as 1 when they match. I want to know the center of that circle, and I want to know the radius.
-2, 3, and 5. Is the center -2, 3, right?
How'd you get negative 2, 3?
That is completely the square twice.
Absolutely. What you have to do in order to determine the center and radius, you have. Well, that was good. I just didn't expect somebody to give me the right answer just like that. In order to find the center and radius, you have to put the equation in this form. In order to get the equation in this form, what you have to do is complete the square on the x's and complete the square on the y's. That's exactly right. So you're going to write this as x squared plus 4x. I like to leave a little space. Plus y squared minus 6y equals 12. You complete the square for the x's. So what's the magic number you need to add in order to complete the square for the x's? 4. You take this number 4, you divide it by 2, that's 2, and then you square it. So you add a 4. And when you add 4, you got to do it to both sides. And the magic number here? 9. That gives you x plus 2 squared plus y minus 3 squared is 25. Which means your center is the point -2, 3, and your radius is 5. Questions on that? All right, so that's a quick review of circles. How about parabolas? What's a parabola? Yeah, it looks kind of like that. I agree.
X squared is the highest power.
X squared is the highest power. What about the y?
Usually 1, right?
Usually or always?
Always.
Usually, because you can add them horizontal, can't you?
So the equation is going to have a y and an x squared, or it's going to have a y squared and a x. So we're going to talk about parabolas that open up and down, and we'll also talk about parabolas that open left and right. And we'll see, it depends on which one is the square. So that's how you're going to recognize the equation. Parabolas are going to have either a y squared and an x, or an x squared and a y. One of them will be squared, but not both of them.
Couldn't the power be any even number? X squared?
No, because if it's y to the 4th, you don't get a parabola.
Oh, that's not a parabola.
You get something that looks kind of like a parabola.
But more narrow.
It's more narrow. It's not quite a parabola. It looks a lot like a parabola, but it really isn't. Okay, well, a circle, our definition of a circle was All points are the same distance from a fixed point. A parabola has a description like that too. Anybody know the classic Greek definition of a parabola? Oh, classic Greeks, huh? For a parabola, you have a point called the focus. And then you have a line known as the directrix. The parabola is all points that are equidistant from the focus and the directrix. So for example, if I go exactly halfway between the focus and the directrix, that's one point right there. Another point out, this is going to be a pretty wide parabola. This point is maybe on the parabola. If this distance, I'll call this one distance 1, and that distance 2, are exactly the same. That's how points get on a parabola. Points are on a parabola if their distance from the point to the line and the point to the focus are exactly the same. So this one I think would be quite a wide, slowly opening parabola. And we might have another point, say here. And again, for this point to be on the parabola, that distance and that distance would have to be exactly the same. They don't look at in my picture. My picture's not drawn correctly, but that gives you the idea. All right, this distance from the focus to this point right here, what's this point right here called? This one's called the vertex. This distance from the focus to the vertex is traditionally called P. A parabola that opens up or down like that has the formula 4p times y minus k equals x minus h squared. That's not the same way that we usually write the equation for parabolas. How do we usually write the equation for parabolas?
Y equals x squared plus x plus c.
Right. Normally we write our equations as y equals ax squared plus bx plus c, or occasionally you see them written as y equals a times x minus h squared plus k. Occasionally you see them written that way. For this parabola that I have written this way, and this one over here, the h and k are something very important. What are the h and the k? That gives you the vertex. The vertex is traditionally called h comma k. Parabolas have a very interesting property in connection with this focus. Anybody know the importance of the point called the focus?
So from the vertex to the focus is the same distance from the vertex to the vertex.
That's true. The distance here is p. The distance there is also p. That's true. That's not what I was thinking of, though. The very important property is if you have a parabola like so, and you have, say, a light wave coming in or a sound wave, and it hits the parabola, that wave will bounce no matter where it hits and go right to the focus. That's why that's called the focus. All the energy bounces and goes right to the focus. So how is that useful? That's how a satellite dish works, except a satellite dish is not a parabola. A satellite dish is a three-dimensional parabola. What do you call a three-dimensional parabola? A bowl. Looks like a bowl. The fancy math name is paraboloid. Three-dimensional parabola is called a paraboloid. That's exactly how satellite dishes work. That's why the satellite dishes have that arm that stick out in the middle. That arm at the end is right at the focus. And all the signals come in, bounce off the paraboloid, and get focused at the focus. That's why it's called focus. What else uses that property?
Is it for sound? Auditoriums?
Yeah.
Auditoriums use that for acoustics. You'll see if you watch professional sports on TV, there'll always be guys standing around with these big paraboloids pointing them at the players, and that's how they pick up the sound. What else?
Lenses,
Such as?
like in a camera or glasses, maybe.
Lenses in a camera, your glasses, your eyes are all in the shape of parabolas. The difference there is the light's coming this way, and it hits the parabola, and it still bounces in that direction. But what happens in your eye? What happens to the image? It flips, because when it comes in this way, the image goes that direction, and this one goes that way. So the image actually flips. So you see everything upside down. Why do some people need glasses?
The shape of that isn't perfect.
There's two possibilities. One, the shape of this is not perfect. That's the more common one. Two, the other thing that happens is this isn't paper thin, this has some thickness. For some people, the thickness is not consistent, and that's called an astigmatism. I happen to have a very bad astigmatism in my left eye. My contact lenses are able to correct it. So my contact lenses fix the fact that what's that called, the cornea, I think? My cornea is not a consistent thickness. My contact lenses are able to fix that and make it so I can see better. Another good example of this is a flashlight. A flashlight works the opposite way. If you've ever taken a flashlight apart, there's a light bulb that sits right here, and then you've got a parabolic dish that's usually in a mirror. So what happens when the flashlight turns on? The light comes out and bounces off, and all goes out in the same direction. That's how a flashlight works. That's how the headlights on your car work. Sort of. What do I mean by sort of? For your car. You ever take your headlights apart in your car? There is a parabolic dish there, but what else happens in your car? How many light bulbs are there? There's 2 light bulbs. Why are there 2 light bulbs? One's the low beam, one's the high beam. The high beam usually is offset a little bit. It's usually not right on the focus. Why would you want it to be offset a little bit?
Wider.
Because then it won't all go out the same direction, it will actually spread. And so your high beam light bulb is usually offset one side or the other, causes it to spread out more, so you get a better view. The low beam is usually set very, very close to the focus, so that your light goes out straighter, so you're not blinding the guy coming at you. So if you ever take apart a headlight, that's how they look. All right, so what are we going to have for questions here? All right, so I might give you this problem. I might say, I should say, what happens if the parabola opens left and right? How does that change the equation?
You just flip the X and Y there.
You flip the x and y, so you're going to have 4p x minus h equals y minus k squared. For the parabola to open left and right, it's the y that gets squared. Okay, so here's a typical homework problem you're going to see. I'm going to tell you you have a parabola. I want your vertex to be, I don't know, somebody give me a good point. Anybody know what the vertex should be? 0, 0. Make it easy. There you go. There's a good idea. And I want the focus to be, what do you want your focus to be? 0, 3. 0, 3. My first question is this parabola opening up, opening down, opening left, opening right? Up. Right. Down. Left. Those are all possible. Which way? Up. Why up?
Because the vertex is below the focus.
Because the vertex is below the focus. So you start thinking about your picture here. You've got your vertex there. You've got your focus here at 0, 3. So the parabola has to go kind of around the focus like so. So this is definitely a parabola opening up. My pen's running out of ink. I have another one. Here we go. So since my parabola is opening up, I know my equation takes the form 4p times y minus k equals x minus h squared. I want to know the equation of that parabola. What's p?
3.
P is 3, because p is the distance from the focus to the vertex. That distance is 3. So that's going to be 12 times y minus, what's the k number? 0, because the vertex is 0, 0, equals x minus 0 squared. So I guess this is the equation, 12y equals x squared. All right, that was an easy one. Give me a vertex this time that does not sit at the origin. 3, 5. And give me a focus.
3.
Let's make it 3, -8. Which way does this parabola open? Up, down, left, right? Down. Because we have 3, 5 right here, say, and then 3, -8 is our focus, so this one goes down. So we still know we have 4p times y minus k equals x minus h squared. How does this change the final answer?
X squared is negative.
P is going to be negative. You're right. Basically, the way we think of it before is we need a negative in front of the x squared. But you can think of that being the p being negative and then divide by p and you'd have the negative over there. So p is going to be a negative number in this case, that's all, to make it open down. What's the value of p? 11? 13?
13.
From 5 to -8 is -13.
Yeah.
So we're going to have 4 times -13 y minus k, y minus, oops, what's the k number? Y minus 5, because our vertex happens at 5, equals x minus 3 squared. Okay, how about x equals, oh, I don't know, give me an equation that has an y squared in it.
3y squared
Plus
5.
6y. 6y. Make life a little bit easier on ourselves. My question is, what kind of shape is that?
Not decided.
It's a parabola. How do you know it's a parabola?
1 squared.
One is squared and the other is not. Does it open left, right, up, or down? To the right. The y is squared, which tells you it opens left or right. Since that's a positive number, that tells you it's going to open to the right. I want to know the vertex, the focus, And I'm going to be greedy. I want to know the directrix too. What do I have to do to find the vertex, the focus, and the directrix? Well, I've got to rewrite this equation. I've got to rewrite it so that it looks like 4p times x minus h equals y minus k squared. I need to take that equation and rewrite it in that form. How do I do that? Well, take a look at the right-hand side. I need sk whole thing squared. How do I take 3y squared plus 6y and write it as a y minus k whole thing squared? Pull the 3 out and complete the square. So there's going to be lots of completing the squares in this section. X equals 3 times y squared plus 2y. So you guys told me 5. I changed it to a 6.
Thank you.
Because I didn't want to deal with the fractions. So being lazy, cheap. All right, so we got to complete the square. That's going to be 3 times y squared plus 2y plus 4. 1. You take 2, you divide it by 2, that's 1, and then you square it. If I add a 1, I can't just add a 1, I got to balance that out by subtracting 3. Why do I have to subtract 3 when I only added 1? Because I'm multiplying by 3. I put that 1 inside this parenthesis, so I really didn't add a 1. I really added a 1 times 3, which is a 3. Okay, I'm going to take this 3 and move it over here. So that's going to be x plus 3 equals 3 times y plus 1 squared. All right, so I'm getting closer. I needed a y minus k squared. I have a y minus a negative 1 squared. That's okay. What am I going to do with that 3? Move it over. So that's 1/3 times x plus 3 equals y plus 1 squared. Yeah, I really need to have this 4. The formula forces me to have a 4. Do I have a 4?
Yes and no.
Yes and no. I don't have one, so what am I going to do? I'm going to make one. So I'm going to put a 4 here. What's the penalty for putting a 4 there? Multiply by a 1/4 to balance it. So my equation, written in the proper format that I need, is 4 times 1/12 x plus 3 equals y plus 1 squared. So P, in this case, turns out to be the number 1/12. Now I can answer all my questions. What's my vertex? -3, -1. And remember, we decided -3, -1 is right there. We decided this parabola was opening to the right, like so, which means my focus has to be right about here. So where's my focus?
1/12 to the right of
1/3.
3.
1/12 to the right. That's correct. And I'm just going to write it that way. I'm going to write it as -3 plus 1/12, comma, -1. The focus simply moves 1/12 to the right in this case, because a parabola is opening left and right. And then remember, the directrix is this vertical line over here. What's the equation of that vertical line? be negative 3 minus 1/12. So the directrix, since it's a vertical line, its equation is x equals a number. In this case, it would be negative 3 minus 1/12. 1/12 unit to the left. Questions on that?
What's the relationship between focus and number 4?
Where the number 4 comes from, if you, I'm not going to work it all out, but what you do to find the equation is you pick a point here and you call it x comma y, and then you find that distance. What's that distance? How would you find that distance?
No, it's not.
That's necessarily not at the height 3. It would be y plus p. That distance would be y plus p. And then, how about that distance? And that looks like a horizontal line. Don't assume that it is a horizontal line. How do you find the distance between 2 points? You use the distance formula. So that's going to be x minus 3 squared, I'm sorry, x minus 0 squared plus y minus 3 squared square root. And what ends up happening, you take this distance and you set it equal to that distance, because that's the definition of a parabola, and you solve for y. And in the process of solving for y, when you square, you have a 2 inside, and then you got to square again, you end up with a 4. And that's where that 4 comes from. It just comes from using the distance formula, working out the problem, and seeing what happens. And it turns out that a 4 just pops up in the problem, okay? But that's the idea of how you would get that formula. Other questions?
So as the P gets bigger, will the parabola get wider?
So as the P gets bigger, will the parabola get wider? Yeah, I think so. I mean, just doing a rough sketch here, if this is my vertex and this is my directrix, I'm sorry, if this is my focus and this is my directrix, my vertex would be there. And then I would need, if I were to pick another point, I would need that distance and that distance to be the same. So if my parabola looked like this. But if the p-value gets bigger, this is still your focus, this is your vertex, this is your directrix. So a point here, another point here would have to have this distance and that distance be the same. So I think it would widen it out. The bigger your p-value, the wider the parabola gets. Or the other answer is, look at your equation here, we have 4p times y minus h equals x minus k squared. You could write this as y minus k equals 1 over 4p times x minus h squared. And what does this number in front, when we have it written this way, do to this parabola? Think of your standard formula, y equals ax squared plus bx plus c. What does that a number do to your parabola?
The direction.
It tells the direction up and down, and it tells
How far up it's shifted.
not how far up it's shifted, but it tells you if this is tall and skinny or if it's short and wide. And when is it tall and skinny? It's tall and skinny when this number is big. Short and wide when this number is small. So when p gets bigger, this number is going to get smaller. which is going to make the parabola shorter and wider. So yeah, as p gets bigger, your parabola gets wider. Absolutely. Other questions? All right, what's an ellipse? And you're not allowed to say it's a squashed circle. Anybody know what an ellipse is? It has A and B, and what are A and B?
It's a circle with 2 focus points, kind of.
It does have 2 focus points, kind of, yeah. No, exactly, it has 2 focus points. Okay, so here's how you make an ellipse. You take a string, or in this case a TI wire, and you create 2 focal points. So where I'm putting the tape, those are the focal points. And then the ellipse, this might be too stiff. The ellipse is, this wire isn't going to work very good, but you'll get the idea. The ellipse is drawn like so. Oh boy. This works better if you have a piece of string. Unfortunately, I didn't bring a piece of string with me today. There, that side is better. Basically, the idea is you have 2 focal points, here and here. If I stretch it out, then the distance from here to here plus the distance from here to here is always the same. So the sum of this distance and that distance are always the same. And it doesn't matter if I put it over here, then I would have that distance plus that distance, but it's still the same length of string, isn't it? So that's the classic definition of a ellipse. So ellipse is the sum of the distances from 2 points are always the same. And those 2 points are called the foci. The plural of focus is foci, not focuses. And so an ellipse would look something like that. That's terrible. But you know what an ellipse looks like. So if I were to take this distance plus that distance, it would always be the same no matter where I drew my point on my ellipse. An ellipse, oh, go ahead.
Do those foci always have to be either horizontal or vertical from each other, or can you have it skewed
In this class, our foci will always be horizontal or vertical from each other. The reality is they can be this way, and then you get an ellipse going in that direction. And you can do the same thing with a parabola. Parabolas don't have to open up and down, left and right. They can open at diagonals, but we don't cover that in this class. That would usually be covered in a class called like plane geometry. Basically what you do, if you want an ellipse that opens at an angle, you create your ellipse this way, and then you do what's called a rotation of axes. And so that's how you would get an ellipse that goes at a diagonal. You would start with an ellipse that doesn't, and then do a process called rotating the axes. Same with a parabola. For us, we'll only deal with ellipses that go this way or that way. Anybody know the special property of an ellipse? The special property of an ellipse is if you have a sound wave or a light wave starting at one focus, it will hit the ellipse and it will bounce to the other focus. So what's that good for? There is a thing in CMOG where you can sit in the two seats and talk to each other. That's cool. Radios? Maybe, but I'm not sure about that. The way ham radios work is they have a very, I don't remember if it's a very long or a very short radio wave. I think it's very long. And they actually go into the atmosphere, and there's a layer in the atmosphere where radio waves bounce off. There's a name for that. There's something layer, but I can't think of the name of it right now. But that's how radios are able to go a long way. They actually go and bounce off the atmosphere and come back down. I knew that name just a few days ago. Anyway, ellipses. Anybody know what ellipses are good for? There is that thing in CMOG where you sit in one seat and somebody else sits in another seat and you can whisper and talk to each other.
What's a three-dimensional?
It's an elliptoid. That's correct. It's a three-dimensional ellipse. When I was at Kansas State University in the math building was called Cardwell Hall. They had a big parabola at one end and a big parabola at the other end, and the building was probably like the same length as the science building here. And you could stand at one end and whisper into the parabola, and somebody at the other end could hear you because you were standing at one focus and they were standing at the other focus. You could talk back and forth using parabolas. The Science Museum up in Rochester has a similar deal outside where you can stand at the two parabolas and whisper to each other and talk. Kind of cool. Anybody ever seen an ellipse used for something?
Somebody did it in ninth grade with like in earth science with like earthquakes or something. I don't know. I think they used something to see the distance that it could possibly affect or something. I have no idea. I'm just
I do think they use ellipses to figure out the center of the earthquake.
right.
Based on the strength at various points, I think they use ellipses to figure out the epicenter of an earthquake. The one example I saw, a number of years ago, my father had kidney stones. And you know what they do with kidney stones?
Hit them with, no, not radiation. Seismic.
They hit them with seismic waves, and that causes the kidney stones to break up, and then you can pass them naturally. And the way they do that is they sit you in a big tank. And they usually put some radioactive dye in your bloodstream so they can see where the kidney stone is, they can see where the blockage is. And then using the radioactive dye, they put you on this bed and they move you up and down and left and right just slightly until they get that kidney stone sitting right at one of the foci. And then the waves emanate from the other foci, and you're in this big elliptical tank, and the waves bounce off, go right to the kidney stone and shatter it into tiny little pieces, and then you can pass it naturally. And so a number of years ago, I took my father to the hospital to have kidney stones removed. And I saw the tank, and I got all excited, and I was explaining to the technologist how it worked, and he's like, just shut up, I got to get your father in the right spot. I said, but this is cool. I can use this in my classes. He wasn't so excited. But he did break up the kidney stones, and my father felt much, much better, so that was good.